In this video, we want to discuss quadratic functions, polynomial functions, related equations, and inequalities. So we've got up to over 25 questions. So make sure you watch to the end to understand all this. So I'll be brief, direct, and precise in my explanations to make sure that you understand. So question 1 says, our function f of x is equal to negative 2x squared plus 2x plus 1. That is our quadratic function. So we are told, by completing the square, express f of x in the form f of x is equal to ax plus b squared plus q, where a, p, and q are constants. So there are two ways that we can handle that part. The first way is by completing the square, as the question states. Okay. So how do you go about that? So our quadratic function itself has been given to be negative x squared plus 2x plus 1 is equal to 0. So every time you want to complete the square, you need to make sure that the coefficient of your x squared should be a positive 1. So in this case, we are going to divide by negative 2. So dividing the entire equation by negative 2 is more like factorizing the negative 2. So I'll factor out the negative 2. So if I do factor out the negative 2, the first part, if I divide by negative 2, I'll get just x squared. The middle part, I'll get negative x. And then 1, I'll get minus half. So remember, I'm dividing by negative 2 throughout. The basic concept is, if you were to multiply by the number that we've put outside, you should be able to get the same result. So that's what we have. So at that point, we can basically now get to complete the square. So the way we basically get to complete the square, the method that I like using is, I'll maintain the negative 2 from outside, and then inside, remember, we've got x squared minus x. So what I'll do is I'll take the other part, which is c, which is negative half, to the other side, so that becomes a positive half. That's what I usually like doing. And then I'll ask myself to say, if I look at what I have, what is the coefficient of my b? So the coefficient of my b in this case, our b is negative x. Remember, the form of the quadratic function is ax squared plus bx plus c. So we always focus on b. So what we basically do is, we'll get the half of b. So the coefficient of negative x in this case is negative 1. So our b is equal to negative 1. The half of negative 1 is negative 1 over 2. So whatever we'll do is, we'll square it on both the left and the right hand side. So I'll maintain the negative half outside. So we're going to have x squared minus x. Now we'll add the square of the half of b to both the left hand side and the right hand side. So the right hand side, remember, we've got our half, so plus negative 1 over 2 squared as well. So the moment you do that, we are going to complete the square by ignoring now the b part. So the negative x will go away. So we basically remain with x squared plus negative half squared. So instead of writing it in that form, we can basically just pull out the square directly by saying x minus half in brackets squared is equal to, on the other side we've got half, plus, now negative 1 over 2 squared is going to give us 1 over 4. So we've moved now. So at this point, we should be able to correct the like terms. negative half, so maintain the left. So 1 over 2 plus 1 over 4, the common denominator is a 4. 2 into a 4 will give us a 2. 4 into a 4 gives us a 1. 1 times 1 will just be 1. So we're getting a 3 over 4 on the right hand side. Now if it gets back to the left hand side, it will become negative 3 over 4. So that we just have it being equal to 0. So we've basically completed the square. That's how you go about completing the square. Make sure first of all, before anything, you need to make sure the coefficient of x squared should be a 1, and then basically get to add the square of the half of b to both the left and the right hand side. So at this point, I believe our equation now is in the form of is it in that form already? A, and then you've got x plus p, 2 plus q, and all that. So I believe we've placed it now in that form. Okay. Now the second part of the question says state the maximum or the minimum point of a function f. So usually we expect that the x coordinate of that maximum or minimum point will be equating what is in the brackets equal to 0. So in this case, in the brackets, we've got x minus half. So if you equate to 0, in other terms, I say you only change the sign of the constant you're adding there. So it will just become positive half. And then this one is expected to be the y coordinate, so that it will be 1 over 2, comma, negative 3 over 4. So let's try to prove that. So the other way you can be sure that you are correct is there's this formula that I usually like using, negative b over 2a. It's also used for finding the x coordinate of a turning point, the maximum of the minimum. So your negative of b, your b in this case, remember, look at that equation. That is our equation. So your b there is a 2, so it will be negative 2. Your a is also negative 2. So you get negative 2 over negative 4. So you get a positive half, which is correct. Now you can also find the y coordinate by substituting in the entire equation. So if you are to plug in the equation, remember we've got negative 2. Where there's x, we put 1 over 2. It will be 1 over 4. Again, the middle part we put half plus 1. The first part we're going to have negative 2 over 4. The middle part we're going to have a 1 and a 1. So we have like negative half plus like 2. So 2 times 2, that is obviously going to be a 4. Negative 1 plus 4 over 2. You basically get to have what? What's the expected result? So that is also going to be 3. Is it 3? Negative 1 plus 4 is what? 3 over 2. So 3 over 2 is the expected result, right? So what have you noticed there? We're getting a 3 over 2. So that now begins to question our answer there. Where did we miss it? So remember, this equation was in the form of 3 over 4 equal to 0. Now, the question I was asking, is it in the form? Is it already in that form? So it's not in that form, right? Because we need to distribute the a only to this part. So we'd have to distribute the negative 2 there. So we're going to have negative 2 x minus half squared, and then you basically get to multiply the negative 3 over 4, which is obviously going to give us what? The 2 into the 4 gives us a 2, so it will be a positive 3 over 2 being equal to 0. Now it's matching up in that form. Now this now makes sense, so that the equation will just be like 1 over 2 comma 3 over 2 as our turning point. So what is our maximum point? So basically each time you have a negative a, that first part being a negative, just know that it's a maximum. You're going to have a maximum turning point. So the question now says we need to graph the function. We need to graph the function. So the computing the square method has allowed us to get to a point where we have our maximum point. So all we just have to do is basically just get to find we just need to find the x-intercept and the y-intercept. Now the y-intercept is already part of a function. So our turning point is 1 over 2 comma 3 over 2. So let's say somewhere there. Our y-intercept is the constancy. That's a point where the function is expected to cut the y-axis. So at 1. So 3 over 2 is a slightly higher than 1. So it will just 1 would be somewhere there. So the graph, that to be maximum point, like that. So now your work is to find these points where the graph basically get to cut the x-axis. So you can finish up solving the equation by computing the square, or you can solve this function using any formula of your choice. So remember, we've got negative 2x squared plus 2x plus 1. If you're able to factorize, well and good. The product in this case is negative 2. The sum is 2. What two numbers can you basically multiply? They give you that. You add them, they give you 2. Are you able to think of such two numbers? Okay, obviously, if it was going to be possible, obviously negative 2 is supposed to be part, but it becomes a bit complicated. I don't think so if there are two such numbers. So if you go by the formula, negative of b plus or minus the root of b squared, our b is 2, so 4ac over 2a. So under the square root we've got 4 times 2, that is 8. So 4 plus 8 is 12, right? So I have negative 2 plus or minus root of 12 over negative 4. So at this point, we are already able to see that this is going to be something that we are not able to divide. Remember, sometimes calculators may not be allowed. So I can still show you how far you can go in terms of simplifying. So when you look at 12, I know 12 can be expressed in the form of the product of 4 and 3. So I can just distribute the square root there. Square root of 4, square root of 3. So I believe you did that. So you notice that you're going to have negative 2 plus or minus. Square root of 4 is 2. And then you have root of 3 over minus 4. So at least you like a common fact. You can divide by negative 2 throughout. So that will give me a 1. That will give me a negative 1. That will give me a positive 2 after dividing by 2. So we have 1 plus or minus negative root of 3 over 2. So the two possible results will be 1 minus root of 3 over 2. The other one will be 1 plus root of 3 over 2. So if you look at the two, which one do you think was going to be on the right part and which one is going to be on the negative part? So you can just look at the values. So for me, I feel this one is going to be the positive part, so that's that point. and then the other one, which is this other point, will be 1 minus root of 3 over 2. So those are the two x-intercepts where we expect the graph to cut the x-axis. So we've answered the question in full. Question 2 is asking us to find, for each of the following functions, to find the maximum or the minimum value, and of course to sketch their graphs. So this question is open. This question is open. So we need to find the maximum of the minimum value. So I already told you to say you need to look at the sign of x squared. If it's positive, it has got a minimum. If it's negative, maximum. You can use the computing the square method. So I'll use the computing the square method to answer. I'll answer 2 to help you guide you. Yeah. So I'll answer 1 with a negative. So the first one, of course, is very easy. So I'll answer the first one, and then I'll also answer, let's say, D to guide you, and then you answer the rest. So the first one, how do we find the maximum? So it's going to be a minimum, of course. The procedure is the same. So I'll use the computing the square method so that you basically get to practice more. So x squared plus 6x plus 5. So I said my way of dealing with this is I like taking the constant across the equal sign. It becomes a negative. And then you only go to that step directly if the coefficient of x squared is a positive 1. Okay? So that means that if you look at the other question where we have negative 2x squared plus 11x minus 15, for that one you have to factorize first of all, pull out the what? Negative 2. And then divide the entire equation by negative 2. So you have x squared, and then you have like minus 11 over 2x, and then you have like plus 15 over 2 is equal to 0. Going back to my first one. So my half of my b in this case is 6, the half is 3. So we'll add it to both sides as a square. So plus 3 squared, even on the right hand side, plus 3 squared. And then the middle part has to disappear, remember, right? So you have x plus 3 squared is equal to negative 5 plus, that is 9. So you have x plus 3 squared. Negative 5 plus 9 will give us a positive 4, right? So if you are to answer or solve a quadratic function using computing the square, at this point you can introduce a square root on both ends so that you have x plus 3 plus or minus the root of 4. Your answer can be negative 3 plus or minus 2. But since we just want to complete the square, the negative 4 will go back the other side. So it will be minus 4. So in this case, equate what is in the brackets to 0. So your x coordinate will be negative 3, comma, negative 4. That's the expected turning point. The other way we can prove is I said that this formula x is equal to negative of b over 2a. Our b is 6, and then our a is 1. So your answer is negative 3. Plug in the entire equation, the negative 3. Negative 3 squared is 9. Negative 3 times 6 is what? Minus 18 plus 5. 5 plus 9 is 14. 14 minus 18 is negative 4. Okay, so we're good. Then we can finish up the one that is on the right hand side. So at that point as well, you can take it as the other one. So say negative 2 x squared minus 11 over 2x goes other side, taking the other half the other side. So at this point, what's the half of? So whenever you've got something in form of a fraction, if you want to find its half, the easiest way is just multiplying by 1 over 2. So if I multiply negative 11 over 2 by 1 over 2, we'll get negative 11 over 4. So that's our half. Say negative 2, open bracket, we have x squared minus 11 over 2x. Its half is going to be negative 11 over 4 squared. We do the same even to what is on the right hand side, plus negative 11 over 4 squared. Then at this point we can ignore this middle part, so that we have x minus 11 over 4 squared, and then equal to negative 15 over 2. And then if you square that, 11 over 4 times 11 over 4 obviously be positive. 11 times 11 I believe should be 121. So you're able to multiply that, 11 times 11, so it's 121 over 4 times 4 is 16, right? So at that point you can add the fractions on the right hand side. Common denominator is 16. 2 into 16 is 8. So you can multiply 8 times negative 15. Negative 120 plus 121. So that would be what? A positive 1 over 16, right? It goes back the other side, it becomes negative. So of x minus 11 over 4 squared minus 1 over 16 equal to 0. So remember, this is not where you end. This is not where you end. You need to make sure that the negative 2 only applies to the brackets where we've got a square. So have negative 2 x minus 11 over 4 squared. So as you distribute the negative 2, if you multiply it with the other part, you get a positive, right? Positive 2 over 16. So instead of saying 2 over 16, we'll have 1 over 8 equal to 0. So would you guess the turning point? The turning point would be 11 over 4 comma 1 over 8. Remember, you change the sign of this part and then maintain this other part. So it being a negative, it's expected to have what? A maximum point. So the moment you get this part, it's very easy for you to sketch a function, right? So I don't expect you to have struggles when it comes to sketching. So you have your turning point already. So I showed you to say, I showed you from the previous example how we basically get to solve the values of x using the computing the square. So you will just plot this. 11 over 4 is a positive value, comma 1 over 8. So you just say somewhere there. Now the point where your graph is expected to cut the what? Where it's expected to cut the y-axis is this part. So negative 15. So you can just say negative 15 is somewhere there. So you say the graph will move like that. Remember, I've said the fact that it has got a negative a, that means it has got a maximum point. So but you've shown your turning point already. You can even put it there. 11 over 4 comma 1 over 8. Now these points are also important. We call them the x-intercepts. The y-intercept, we've already said the negative 15. So you can find these by using the computing the square method, or you can even use the quadratic formula to get the values there. Then you've done. the sketching ready. Okay, to just make sure that you get all the marks, but the turning point and the y-intercept are also enough in terms of sketching a function, but you can show the x-intercept since you know how to find them. You want to make sure you get all the marks because that is easy for you to do. Now question 3 is a normal questions, simple questions that you can handle. So you can use factorization if possible, completing the square, or quadratic formula. So the first one says, so always try the factorization because it's easier and faster. They are all easy, but it's faster. So x squared minus 10x plus 24 is equal to 0. We need to solve. So the product, you get the coefficient of your x squared with the c. So our product is 24. Our sum is the middle part, which is b, negative 10. And then two numbers that you can multiply to give you 24, you add them, they give you 10. I feel we can deal with 12 here. 12, 2. Negative 12, 2. And if it was going to be negative, then it would work. No, it won't work. The other two I can think of are 6. 6 can go into 24, I think, 4 times. So unless obviously to be negatives, 6 times 4 is 24, I believe. And if you add them, it gives negative, then right. So at that point, you can say x squared. Now the middle part will be substituted by the factors, of course, with x, and then plus 24. You can factorize. So the other way is just go direct. Just get one x. You say x minus 6, and then x minus 4. So that's why I say factorization is very fast. So x is equal to 6, x is equal to 4. The other way I think about this is like when you get the factors, whenever the coefficient of x squared is a positive one, like your answers are always going to be changing the signs of the factors. So that's how you handle it using a quadratic, using factorization method. So for the second one, I'll show you using the formula, just in case you've forgotten. I'll remind you. So your formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2n. So the basic formula of the quadratic formula I said is ax squared plus bx plus c. So this is your a, that is your b, that is your c. Just substitute in the function. Negative of our b, which is our negative 12. Our b squared is 12. 12 squared is 144, I believe. Minus 4. Our a is 2. Our c is 5. 4 times 2, I believe that is like, okay, 2 times a is, our a is 2. So I was saying 4 times 2, 8. 8 times 5 is what? What's 8 times 5? Isn't that like 40? 8 times 5 is 40. 40 from 144. 104. So square root of 104. So usually in your assessments, they don't allow you to use calculators, so they may not give you such questions. But if they do, just end at this point, okay? Just separate the two. So you say negative 12 plus the root of 104 over 4, and then you put the other one with the negative. Okay, so in case calculator is allowed, just punch that on the calculator. You'll be able to get the two possible solutions to the question. So I believe to such a question, it's not possible for you to basically get to factorize. You can try it, however. So if you are to try that one out, 2 times 5 is going to be 10. 12, two numbers that you can multiply to give you 10, you add them, they give you 12. I don't think so if it's possible. You can think about it. So you can try the last two, which I believe are not different from whatever we've done so far. We're now on question 4. So how do we solve inequalities? There are only two things that I want you to know first of all. So one thing is whenever you're dealing with inequalities, you understand first of what these stand for. When you say greater than, you know what it means, right? Less than, greater than, equal to, less than, equal to. That's very important. So the first thing that I would want you to know is whenever you're dealing with the quadratic inequalities, each time you want to solve them, make sure you get to find the zeros of that equation. So the zeros of that equation basically are, these are points where of course we expect, it's more like you consider it to be an equation instead of an inequality. You ignore the fact that it's an inequality, you solve it as an equation and then find those 0 points. So let's say you have a certain quadratic function and then you get to find these 0 points. Let's say -2 and +1. So you will put them on the number line now, and then you use them to perform testing. So we'll be testing by getting the number in between and the numbers outside these to help us find the region where the inequality will be satisfied. Okay, so all that will make sense. So these are the two steps: finding the zeros of the equation and then using the number line to determine the region which will satisfy the inequality. So if I look at A, for my A, I have x squared minus 4x, and then that is like greater than 3. So I can take them on one side first of all, so that we come up with an equation. X squared minus 4x minus 3 is greater than 0. So we can ignore the fact that this is an inequality, and then we try to answer it as an equation. We find the zeros of that equation. The other way we basically do this in a better way is, if this part is factorizable, it's even better actually. So the product there, I already showed you how to find the product. So the coefficient of your x squared and your c, and then the sum is the b, which is -4. What two numbers can you multiply to give you -3? You add them, they give you -4. So I believe the numbers there should be -3. Is it -3? If you try -3 and 1, those ones won't work, because if we add -3 and 1, they'll give us a -2. Okay, it's a bit tricky. It's a bit tricky for that one. So in a case where you're not able to do it directly to factorize, I don't know, maybe I'm just thinking too much. Maybe you've already come up with an answer. Okay, but anyway, I've failed personally. So I'll solve the zeros of the equation using the formula. So my x is equal to negative of b plus or minus b squared. My b squared is -4 squared, which is 16, minus 4ac over 2a. So we have our a in this case is 1. So we have 4 plus or minus 4 times 3. That will give us what? 12. 4 times 3 is 4ac. Yeah, 4 times 3 will give us a 12. So 16 plus 12. 6 plus 2 is what? 6 plus 2 is 8. And then 1 plus 1, that is 28. Okay, so 4 plus or minus 28. 4 plus or minus the root of 28. So root of 28 is something like 5.29 over 2. 4 plus that divided by 2. So one of the possible results are 4.645. So that is for the addition part. So we'll have to also find for the subtraction. So subtraction, I'll say 4 minus root of 28 divided by 2. So don't worry if calculators are not allowed. If they're not allowed, they'll give you the ones that you're not, there's no need for you to use a calculator. So this one is negative 0.6456. So those are the two answers. So now the way you get to handle your inequalities like this. So we've already found the zeros of the equation. And then we'll try now to answer the inequality. So the negative part is negative, I'll take it to be negative 0.6. And then the other part is take it to be 4.6. So the way you get to basically solve the inequality is you look at these regions. So I think of a simple number between negative 0.6 and 4.6. So I feel 0 is a number in between. I think 1 is also between these numbers, but I'll go for 0. Okay, we can even pick a 1 if you want. And then after 4.6, I can immediately think of a 5. Then less than negative 0.6, I can think of negative 1. So we'll use these numbers to trace which region will give us and the number, or satisfy that inequality. The inequality tells us the left hand side should be greater than 0. So what values of x? So if I get a 0 and I plug it into that inequality, these parts will be eliminated. We'll get a negative 3. So now the question is negative 3 greater than 0? That's not true. Negative 3 is less than 0. So the middle part already fails. If you're not satisfied, you can also try another one. I believe 1 is also still between negative 0.6 and 4.6. So if I get a 1, I plug into the equation. 1 squared will be 1. Negative 4 times 1 will be minus 4. So we'll get 1 minus 4, we'll get the minus 6 there. That is also not true. Negative 6 is not greater than 0. So we can quickly try the left hand side. So in most of the instances, whenever the middle part refuses, the left and the right hand side usually agrees. But sometimes only one side agrees, so we'll have to try it each time. So if you put a negative 1, negative 1 squared will be a positive 1. If you put y as x, you put a negative 1, it will be a positive 4. So you have got 5 minus 3, which is a 2. So 2 is greater than 0. Right, true. So the left part has agreed. You can try the right part, the right hand side. After 4.6, we can try 5. 5 squared will be 25. 4 times 5 will be 20 minus 3. So 25 minus negative 23, that is like a 2, which is also true. So the right hand side has also agreed. So the way we can present these solutions is, first of all, values that are less than negative 0.6 have agreed. So x values that are less than negative 0.6. The actual value was 6, 4, 5, 6 like that. And then x greater than 4.645. These are the values that are in agreement. So if we add an equal to thingy down there, line down, equally our result would also include a dash. If the middle part had agreed and the other two parts would have refused, our answer was going to be negative 0.6 is less than x, x is less than 4.6. That's how we present the solution in between. Okay. So we've answered an inequality where we are not able to factorize. I can now answer B. which I believe is factorizable. So x squared minus x is greater than 12. So we can take them on one side. So I said your first step is to find the zeros of the equation. You consider it to be an equation. So in this case, the product 1 and negative 12 gives negative 12. Our sum is the middle part. What two numbers can you multiply to give you that? 4 and 3, I believe, with a negative 4. Negative 4 times 3 is negative 12. And of course, if you add them, they'll give you a negative 1. So therefore, we have x minus 4 and then x plus 3. So if you multiply those two, you expect to get that equation. So therefore, the zeros of such an equation, you just like equate this to 0, you'll be able to find the answers. So in this case, the answers are visible already. The zeros of the equation are visible. Okay. So if you cross the other side, you have a negative 3, you have a positive 4. So think of a number in between negative 3 and 4. Obviously 0 is. So if you plug in 0 into the both of the brackets, here you remain with a negative 4, there you remain with a positive 3. What answer will you get? Negative. Now is a negative 12 greater than 0? No. So the middle part has already refused. So I'm already suspecting the left and the right answer will be the possible solutions. If I try a minus 4 here, negative 4 minus 4, negative 8, negative 4 plus 3, negative 1. So those will give me a positive result, which is 8. 8 is obviously greater than 0, so that has already agreed. If I get a number greater than 4, let's say 5, in the first bracket, 5 minus 4 is a 1. 5 plus 3 is 8, so that is also agreeing already. So therefore, our the range of the possible values of x to satisfy that inequality should be values that are less than negative 3 and values of x that are also greater than 4. So that's it for B. So whatever we've done here applies to everything else that is below. Maybe just for the sake of the practice and just to help you understand more, I can handle question E, which looks a bit is of course facing the other side, and then it has got an equal part. So 2x squared minus 10 is less than or equal to 5 minus x squared. So the best way of handling that question is by correcting the like terms. So I have 2x squared going the other side. So the x squared will go the other side, minus 10, and then minus 5, so that we just remain with a 0 on the right hand side. So we have 3x squared, and then minus 15 less than or equal to 0. So that's our inequality there. So the question you can ask yourself is, if you're able to factorize, please do so. So I'll factorize my 3, and then we'll have x squared, and then my 3 into 15 will be 5 times. So we said, first of all, find the zeros of that equation on the left, where you consider it to be an equation. You ignore the fact that it's an inequality. So if I've got x squared minus 5, when can that be equal to 0? So that can be equal to 0 when x squared is equal to 5. So my possible values of x are plus or minus root of what? 5. Those are the possible values of x that will be able to give me zeros. So I have my zeros of my equation now. It's just a matter of now testing. So we have negative root of 5, positive root of 5. So you should have at least approximations. You know that the root of 4 is a 2. So you expect that the root of 5 is a number bigger than 2. So it should be 2 point something, right? So 3 is greater. Negative 3 is less than. That's the way we can think about it in a smarter way. So I do believe we have a 0 there. So we've already come up with numbers that we can use for testing. So if I put a 0, if I plug in a 0 in the inequality there, I'll remain with a negative 5. Negative 5 multiplied by the 3 outside. So my answer will still be a negative. So the question is negative 5? So it will actually be negative 15. So is negative 15 less than or equal to 0? So negative 15 is obviously less. So for me, I feel the middle part has agreed. So the fact that it has agreed, I believe the other two should refuse. Let's try it. I'll get a negative 3, which is less than the root of negative 5, which is less than negative of root of 5. So if I plug in there, I'll have like my 9 minus 5, which is already a positive value. Now a positive value cannot be less than 0. On the other side as well, it will be the same. So the middle part is our possible solution set. So negative root of 5 is less than or equal to x. X is less than or equal to root of 5. Only the values in between the two, including themselves, are able to satisfy that inequality. They'll give us values less than or equal to that. Yes. So this is how you should handle inequalities in a simpler way. So we've talked about both cases where you're able to factorize and also a case where you can't factorize. You should still be able to find the inequality. You should be able to solve inequalities by finding the zeros of that equation, using the number line to test them out. Without solving the equation, we need to determine the nature of the roots of the following equations. So please, if you are tired, like I always say, feel free to pause the video and continue after. So what does the word nature of the roots mean? That phrase, nature of roots. So we use what we call a discriminant. So your quadratic formula says x is equal to negative b plus or minus the root of b squared minus 4ac over 2a. Now what I want to bring to your attention is, have you ever tried solving a quadratic function and then you get a negative under the square root, let's say negative 4? And if you ever tried solving, you get a positive, which is usually the case. And if you ever tried solving, your b becomes, your negative b is a 0, and then plus or minus, let's say root of 4 again. So this will summarize everything. So in a case where you've got a negative under the square root, you can't simplify this. You can't find the values of x. So in such a case, we call that imaginary. Now we call them imaginary roots because such a quadratic function, remember, I said when you're sketching a graph, you can use the quadratic formula to help you find the x-intercepts. So the x-intercepts are also what we call the roots. The roots are the parts where the quadratic function cuts the x-axis. Okay? So if that's the quadratic function, these are what we are calling the roots. Okay? Now in a case where we're saying imaginary, there are some functions that are like that. They don't cut the x-axis. So those are the ones where you can simplify, or where you've got a negative under the square root there. Now in a case where it is a positive value, we call them real roots. Why? Because they are real. They do exist. These ones are imaginary. And then of course, that is also real because it's still the root of 4. But we call them equal roots. You understand why later on. So we've seen that we can have imaginary and real roots. Now I've said for imaginary, what is under the square root there is what? Is a negative value. So we'll be using our b squared minus 4ac, which we call our discriminant, to be able to tell the nature of the root. So if you've been given a quadratic function, you just need to plug in into that. So if you are saying for imaginary, it should be a negative number. Negative, using inequalities, we can just say negative means we are less than 0. So whenever the b squared minus 4ac gives us a negative value, or it is less than 0, the roots are imaginary. Whenever the value is positive, we say greater than 0, the nature of the roots are real. In a case where they are equal to 0, where b squared minus 4ac is equal to 0, they are real because you're able to find the square root of 0, first of all. So they are real, but they are also called equal roots, because whether you say plus or minus, you still get the same result. So you've got two of the same roots being equal. So these are the nature of the roots that we need to expect. So with that understanding, we'll be using our discriminant. So if you forget, just remember what is under the square root of your formula. So for the first one, your b squared there is what? Your b is 20, so you have 20 squared. Your a is a 4, your c is a 25. So 400, I believe. 4 times 4 is 16. 16 times 25. 16 times 25 is also 400. So I'm getting a 0. So I said whenever you get a 0, the roots are what? They are real, first of all, because you're able to find the square root of 0. And then they are also equal. So they are real and equal roots. So it's just like that. You got the next one. You plug in, your b squared is a 4 squared. Your a is a 1. Your c is a 7. So you have 16 minus 4 times 7. I believe that is a 28. And then that is like a negative 12. So whenever you have a negative 12 under a square root, so that is, you can't simplify that. So these are imaginary roots. You can't find the roots. So they are imaginary roots. So your b squared minus 4ac in this case is less than 0. Then for c, you have 16 squared minus 4. Your a, sorry, not 16 squared, 40 squared. 40 squared minus 4. Your a is 16. And then your c is minus 25. So 40 squared is what? 1600. 4 times 16 times 25. So 1616. So 0. So when you get to 0, what did I say? I said equal and real. Then the last one, you can try it out. So you have your b is 5. Your a is 2. Your c is 7. So 25. 4 times 2 is 8. So 8 times 7. Even without finishing that up, I know that is going to be greater than 25. So we get a negative value. When you get a negative, imaginary. Question 6, which I believe is very interesting. We want to deal with the alpha and the beta. So the roots of the equation are alpha and beta. So the equation is 2x squared minus 4x plus 5. One important idea is alpha plus beta should be equal to negative b over a. And then alpha multiplied by beta is equal to c over a. This is of ultimate importance actually. when it comes to the study of these alpha and beta. So negative b over a, what is our b over our equation? Is negative 4. Remember our equation is 2x squared minus 4x plus 5. So b is negative 4, our a is 2. So therefore our answer becomes 2, I believe. Our c is 5, our a is 2. So therefore our alpha beta is 5 over 2. So that's it. So alpha plus beta is negative b over a. Alpha beta is c over a. That's very important. So if we are to simplify everything we've been given here, we should be able to express it in the form of addition and multiplication of alpha and beta. Okay, so I'll start with the first one. The first one we have is 1 over alpha plus 1 over beta. So how easily can you simplify that? So I feel we can come up with a common denominator by multiplying them, and then we can divide alpha into alpha beta, or get beta. Beta into alpha beta, get alpha. So you know, beta plus alpha is just the same as saying alpha plus beta, right? So at that point you're able to simplify. Alpha plus beta we already saw it's equal to 2, and then alpha beta is 5 over 2. So dividing by 5 over 2 is the same as multiplying by 2 over 5. So we get 4 over 5. So we've seen that the basic idea is we have to express it in the form of the addition and also a multiplication for us to simplify. We are on b. So for b we have alpha plus 1, and then we have beta plus 1. So I feel the only way we can get to put it in that form is by trying to like expand this. Alpha multiplied by beta. So I'll start first of all by alpha. I'll multiply everything in the other bracket. So I'll get alpha beta, and then I'll get alpha, and then I'll get beta after multiplying by 1. So that's what I'm getting. So I'll substitute. For my alpha beta, we have 5 over 2. The middle part, alpha beta, is equal to a 2 plus 1. So at least we're able to simplify from there. If we multiply the other parts by 2, 5 plus 4 plus 2. So of course the common denominator is a 2. So we have 5 plus 4 plus 2. 9 plus 2, 11. So you've seen that it's possible for us to express all these in the form of alpha plus beta and alpha multiplied by beta. So if I'm now on C, C is the interesting part, alpha squared plus beta squared. How can you express it in the form of... So this is not equal to this, please. They are not equal. They are not the same. But they are closely related, right? So if I was to have alpha and beta in brackets squared, they look very close, right? So is there any relation between them? So if we try to expand that, alpha times alpha gives us alpha squared. Alpha times beta is alpha beta. And then if you start with beta, beta times alpha, we get alpha beta. So I'm just trying to expand that. And then beta times beta, beta squared. So we now have alpha squared plus 2 alpha beta plus beta squared. So I can say alpha squared plus beta squared plus 2 alpha beta. So on the left hand side we have alpha plus beta squared. So if I'm to make this is a subject, this part would have to go the other side. So if it goes the other side, it becomes negative 2 alpha beta. So therefore, alpha squared plus beta squared is equal to alpha plus beta in brackets squared, removing the middle part of 2 alpha beta. Okay, so in that way, we've expressed it in the form of subtraction, sorry, of addition and multiplication. So alpha plus beta is 2, so 2 squared. And then we have 2 alpha beta, which is 5 over 2. So we have like 4 minus 5, giving us a negative 1. So the basic idea here is not important. The answers we're getting are not important. But what's important is us being able to express in the form of alpha plus beta and the product alpha beta. That's what is important, because we understand that if given that alpha and beta are the roots of the equation, we're able to find the addition of alpha and beta and also their product. So we are on D. At this point, I believe you've gotten the idea behind whatever we're doing. So you can feel free to pause the video and just try this one out. So we can factorize here what's common. I have alpha beta being common. For the first part, if we remove alpha and beta like that, we remain with a single alpha. And then the other part, if you remove alpha beta squared, you remain with beta, I believe. So we are now in the, this is now in the form of product. And so our product is 5 over 2. And then our addition is 2, giving us a 5. Now if we go to E, our E is alpha minus beta squared. So if you try to expand that, you get alpha squared minus 2 alpha beta plus beta squared. So you have alpha squared plus beta squared minus 2 alpha beta. So what we've done after expansion is only this part is in the form of the product. Now alpha squared plus beta squared, if you've got good memory, under C we said that is the same as what? Alpha plus beta squared, it was minus 2 alpha beta. So now there's also an extra minus 2 alpha beta, so giving us 4. So alpha plus beta squared, alpha plus beta is a 2, so 2 squared minus 4 alpha beta is 5 over 2. Okay, so 5 over 2 times that, so of course you get a 4 minus 10, I believe. So you get the minus 6. So I'm sure you've seen the way I'm trying to work around this, trying to just express it in the form of the addition and also product. I'm now on F. If I end from here, you say, no, you've left the odd ones, and then you've answered the simple ones. So I'll finish all these. So I feel since these are fractions, I think we can try. By the way, I'm just trying. I didn't answer these in advance. So I think we can try to like come up with a common denominator or something like that. So if we divide that, you get beta plus 1. Again, if you divide that, you get alpha plus 1. Trying to simplify whatever we have. On top, you have alpha plus beta, and then 1 plus 1 will give us a 2 over. So on the denominator part, if you try to expand that, Alpha times beta will give us alpha beta. Alpha times 1 is alpha. And then 1 times beta is beta. And then 1 will give us 1 like that. So for alpha plus beta, we have a 2 plus 2. Denominator, we have alpha beta, which is 5 over 2. Alpha plus beta is a 2 plus a 1. So you have a 4 over 5 over 2 plus 3. So you can simplify that a bit, I believe. So don't forget our alpha plus beta is equal to negative b over a. So 5 over 2, we can take that as, first of all, 4. Common denominator on the bottom is 2. So we'll have 5 plus 6, 11 over 2. And then again 4 multiplied by 2 over 11, 8 over 11. I've got 2 more. Feel free to pause the video and try them out as well. G, 1 over 2 alpha plus beta plus 1 over alpha plus 2 beta. Common denominator, 2 alpha beta, alpha plus 2 beta. Try to divide. Alpha plus 2 beta plus 2 alpha plus beta. I believe you understand what I'm doing there. So if I just get to divide this into that, this will cancel, I'll remain with that part. I'll multiply with a numerator which is just like a 1. Okay, I'll continue from the bottom. So on top, I can collect alpha and beta, and then we have 2 alpha plus 2 beta. On the bottom, we can continue multiplying. 2 alpha times that, you get 2 alpha squared. 2 alpha times 2 beta, you get 4 alpha beta. And then beta times alpha, you have alpha beta. And then beta times 2 beta, you get 2 beta squared. So you have alpha plus beta on the top, and then you can factor out the 2 so that you have alpha and beta. For the denominator, what can we do about it? So the middle part are like terms, and then we've got 2 alpha squared plus 2 beta squared plus 5 alpha beta. It has come out already. I can continue from the top part. So alpha plus beta plus 2 alpha plus beta. So for this part where we've got 2 alpha, I can factorize 2. So remain with alpha squared plus beta squared in the brackets. Now I believe at this point it shouldn't be a struggle for you to understand the meaning of that. So we already established to say alpha squared plus beta squared is the same as alpha plus beta squared minus 2 alpha beta. So plus 5 alpha beta. So at this point now, all you just have to do is just like substitute, and then you'll be able to get the answers. So alpha beta is a 2, and then 2 alpha plus beta again is a 2, over 2. In the brackets we have like alpha squared, alpha plus beta, which is like 2, and then minus 2 alpha beta, which is like 5 over 2. So that is in the brackets, and then to all to be multiplied by the 2 outside, plus 5 multiplied by alpha beta. So simplify that, you'll be able to get the answer to your G. And then finally, for the last one, you can try it out. I believe the same procedure would have to work. So 1 over alpha squared plus 1 plus 1 over beta squared plus 1. So how do we handle that? So we're going to have the same procedure. We'll come with a common denominator, alpha squared plus 1, beta squared plus 1. So that into that, we get beta squared plus 1. The opposite is true. We get alpha squared plus 1. So we have alpha squared plus beta squared on top, plus 2. Denominator, alpha squared times beta squared will give us alpha squared, beta squared, alpha squared times 1, alpha squared, and then beta squared plus 1. So I believe this is easy and has already been simplified. So for the top where we've got alpha squared plus beta squared, we say that can be grouped and will give us alpha plus beta in brackets squared, but you have to remove 2 alpha beta, so plus your 2 over the denominator. We also have so where it's alpha squared beta squared, that can just be the same as alpha beta in brackets and then squared, and then the middle part is also there, so alpha plus beta minus 2 alpha beta plus the one that's there. So you'll be able to plug it into that and you'll be able to get your answer. So notice that we have that part. That's why I've put again alpha plus beta squared. I already showed how we came up with that. Minus 2 alpha beta. And then plus the 1 at the end. We'll handle question 7. Also based on the idea of alpha and the beta. Now don't forget what we said. So I said alpha plus beta is equal to negative b over a. Okay, so in this case, if you look at that equation, we've been told alpha and beta are equally the roots. So negative over b over a, so still be a 4. And then alpha multiplied by beta is equal to c over a. So our c in that case is 2, our a is still 1, so we've got 4 and 2 respectively. Now the question is asking us to find the equation whose roots are the ones written below. So take note of what I've, so the only thing that the given equation helps us to do is find what the summation and the product are. That's all. That's the only thing that helps us with. So everything else is to be the same for the new equation. So if you look at part 1, we have alpha plus 3 and beta plus 3. So the new roots as well, they are to be added. So I'll add alpha plus 3 plus beta plus 3, and then they are also to be multiplied. So alpha plus 3 multiplied by beta plus 3. So I need to put them as well in the form of alpha plus beta and also product. So 3 plus 3 is 6. Then that side, if I multiply, we're going to have alpha beta and then 3 alpha, 3 beta, plus 9. So they also need to be in the form of, so I'll factor out the 3 so that we've got alpha plus beta in between, and then plus 9. So we need to find the exact values, the numerical values of these. So what's alpha plus beta? So we already established it's equal to 4. So 4 plus 6, giving us a 10. Here alpha beta is a 2. Alpha plus beta is a 4. And then plus 9. 9 plus 2 is 11. 11 plus 12. So we have 23. Now, what you need to understand is where are they coming from? The 10 is coming from the addition of the roots. So addition, we said, is equal to negative b over a. And then we said multiplication is equal to c over a. So one thing that we'd have to establish the fact that a should be the same value. Okay? So therefore a is already equal to 1. Now if I get to equate negative b to be equal to the 10 there, my b will be equal to what? Negative 10. And then that side, if I equate my c, remember we've got c over a is equal to 23. So a is already equal to 1, so c is equal to 23. So our equation becomes our a is 1. So it will be x squared minus 10x plus 23. That's the new equation for part 1. So for part 2 as well, we'll do the same. Now for part 2, we have alpha plus 3 beta, and then we have beta plus 3 alpha, sorry. So also add. So if we add them, we have alpha plus 3 beta, and then plus beta plus 3 alpha. We also have to multiply them. Alpha plus 3 beta multiplied by beta plus 3 alpha. So they have to be in the form of addition and then multiplication. So there I can factor out 3, so I have that. Then alpha times beta is alpha beta. Alpha times that times 3 alpha squared, 3 beta squared, plus 9 alpha beta. So the middle part, we have to factor out 3. So that remains with alpha squared plus beta squared, which we already established from the previous question. So we already said alpha squared plus beta squared is the same as what? So that's the same as alpha plus beta squared minus 2 alpha beta. So all that is being multiplied by the 3 outside, don't forget, plus 9 alpha beta. So I believe at this point we're able to substitute now. So alpha plus beta, don't forget, that's equal to 4. And then what? So 4 plus 3 times 4, that is 12 plus 4, 16. Then this other part, alpha beta is 2, 3, and then in the brackets we have alpha beta. So alpha plus beta is 2, 4 squared, minus 2 alpha beta, that is 2, and then we've got a 3 outside, plus 9 alpha beta, which is like a 2. So we need to simplify that. So we need to start what's in brackets. So 2 plus 9 times 2 is 18. We've got a 3 there. So 4 squared is 16. 16 minus 4 is 12. So 36 plus 18 plus 2. So that is 20, 56. So the moment they are like that, it becomes easy. So don't forget this was addition. So addition we said is negative b over a. Multiplication is c over a. So your a is equal to 1, your b is equal to negative 16, your c is equal to 56. So equation becomes x squared plus minus 16x plus 56. So hopefully all our corrections were right, but the basic idea is the alpha plus beta and alpha multiplied by beta are calculated using the given equation. And then to find the new equation, you need to use the given roots by adding them and multiplying them respectively as well. Okay? And then you substitute the values of alpha plus beta and alpha multiplied by beta. And then you equate them to find the values of a, b, and c. So using the same concepts, we can proceed under the same question. Now, if the roots of the equation are alpha and beta, we need to also write down the equation whose roots are that. So this one is just like the same from what I'm doing. So you can even go straight by adding the new roots. So we have got 2 over alpha plus 2 over beta. And then you can also multiply them. 2 over alpha multiplied by 2 . So there we can come up with a common denominator, which is like their product. And then alpha into alpha beta will give us beta times 2. 2 beta to alpha. So factor out the 2, you remain with alpha beta, alpha plus beta. Okay, the other side you just have like a 4 over alpha beta, which is already in the form. So at this point now we can find the values of alpha plus beta. So alpha plus beta, I said it's negative b over a. Our b there is 2, so we'll say negative 2. Our a is negative 2 as well, so you get a 1. And then for alpha multiplied by beta, I said it was c over a, so our c is negative 7, our a is negative 2, so you get 7 over 2. We can substitute. So here where I was saying alpha plus beta, it's 1, so it just be 2, and then we are dividing by 7 over 2, so which is the same as multiplying by 2 over 7, giving us 4 over 7. And then there we have 4. Alpha beta is 7 over 2, so multiply by 2 over 7, so equality of 8 over 7. So we found the values of the addition of our roots and their product. So we said the addition is equal to negative b over a, and then their product is equal to c over a. So our a is already matching up. So our a is equal to 7, our b is negative 4, and our c is 8. So we have 7x squared minus 4x plus 8. So that's our equation for having those roots. And then finally, if we have c, the roots of the quadratic equation x squared minus bx plus q are alpha and beta. So that's our equation in this case. So alpha and beta are the roots. Write down the terms of p and q and equation whose roots are. So we need to fire now. So I can start with the roots first of all. So for our roots we have alpha squared plus p alpha squared So we need to add our roots first of all. So add them, beta squared plus p beta squared. And then we can also multiply our roots as well. So we have alpha squared plus p alpha squared, multiply beta squared plus p beta squared. For addition, we need to correct the, remember everything has to be in the form of addition of alpha and beta and also their product. So I'll get the first part, alpha squared, I'll correct it with beta squared, and then I'll also correct the p alpha squared plus p what? P beta squared. So alpha squared plus beta squared, I say that is the same as alpha plus beta in brackets squared minus 2 alpha beta. And then this other part, we can factor out the p, so that remain with alpha squared plus beta squared. Now, equally that can also be expressed in the other form. So I have alpha plus beta as well, squared minus 2 alpha beta. Now these are all being multiplied by the p, which is outside. Then the other part we need to multiply, so I have alpha squared beta squared, and then we'll have p alpha squared beta squared, and then we'll have p alpha squared beta squared, and then we'll have p squared alpha squared beta squared. Yeah, so we need to make ensure they are in the form of multiplication and addition. So that can be written as alpha plus beta and then squared and then plus p. So notice that these are like terms, are they? So what is alpha squared alpha beta squared b? Yeah, those like terms. So take that to be our p. So there are two, so say 2p is common, and then we have alpha beta squared plus the last part p squared. Now those can just be written as alpha beta squared as well. So this is addition, that is multiplication. So we can now find the values of alpha and beta according to the equation we were given. So that is our equation. So our alpha plus beta, we said our alpha plus beta is negative b over a. So negative of b, our b there is negative p, so it will be positive p. Our a is a 1, so it's just p. Then for alpha multiplied by beta, now the product of the two will be able to give us c over a. So our c is equal to q, I believe. Our a is a 1, so we have p and q. We can substitute. So for addition, we have p, so we have p squared minus, so for alpha beta we have a q, so 2q plus p. And in the brackets, alpha plus beta again is p, that is p squared minus 2 alpha beta, which is like q. So there's a p outside there. So which will simplify to p squared minus 2q plus p to the power 3 minus p, let me just say 2pq. The other part, alpha plus b, alpha multiplied by beta is q, so I have q squared plus 2p, that is already q again squared, p squared again, and that is like q squared again. So we have q squared plus 2pq squared plus p squared q squared. So don't forget that this is equal to our addition, which is negative b over a. Then that is equal to c over a. Now the question I would want to ask you is, do you think this can be simplified beyond where we've reached so far? So I can't see the way we can simplify them myself. So the fact that there's nothing on the denominator part, it tells us our a is equal to a1, and then our b becomes the negative of the entire other part. So it will be 2pq minus p3 plus 2q minus p squared, and then our c is this other part. So therefore our new equation becomes x squared, our b is 2pq minus p3 plus 2q minus p2x. Our c is plus q squared plus 2pq squared plus p squared q squared. So that is our form of the equation in the form of p and q. It's all dependent on our understanding of the idea of coming up with a new equation when you're given new roots. Okay, so don't forget, alpha multiplied by beta is equal to c over a. Alpha plus beta is equal to negative b over a. Whatever roots I give you, add them, multiply them, and then equate them to c over a negative b over a at the end, for you to be able to find the values of a, b, and c. You can use the given equation to find the actual value of alpha multiplied by beta and alpha plus beta. Question 8 is very interesting as well. I believe the most interesting question in this paper. Find the values of k, or the range of values of k in each case below. So we're going to use different concepts we know about quadratics that will help us satisfy the conditions given. So actually there are quite a number, including those and also this part. So answer all these. The roots of 3x squared minus 5k to differ by 2. So I want you first of all to understand what roots are. So I earlier mentioned to say, from at the start of the video, to say the parts or the points where the function cuts the x-axis, those are what we call the roots. Now I said the roots can be found using the quadratic formula, completing the square, and factorization. Okay, so I'll use the formula to just show you how we basically get to satisfy that condition. So x is equal to negative b, so our b there is 5, right? Negative 5. So negative of b plus or minus b squared, which is negative 5 squared, minus 4, our a is 3, our c is k itself. over 2a. Our a is 3. So if we get to simplify this, we are going to get positive 5, so which is just like 5. So I'm going to differentiate them. I'll take the positive part, square root of 5 squared is 25, minus 4 times 3 is 12, so minus 12k over 6. The other possible result is where we get minus 5 minus root of 25 minus 12k over 6. So these are the two possible roots that we should get. Now the question says find the value of k where they get to differ by 2. So the argument or the main idea behind our answer is if these two roots are to be subtracted, there should be a difference over 2. So meaning that minus these two possible solutions, they should be able to give us a 2. So I equate that to be equal to 2. So we can see that they've got a common denominator of a 6. So 6 into that, it will be a 1. So our 5 plus root of 25 minus 12k. Now as I distribute the negative to the other part, we get minus 5, and then it will be a positive root because there is already a negative there, so 25 minus 12k. On the other side, we've got a 2. So what do we expect at this point? So 5 minus 5 will go away. Then these are like terms will give me a 2, will give us a 2. So I have 2 root of 25 minus 12k over a 6 equal to a 2. At this point, what I would do in my case is I'll basically divide a 2 there, and there it give me a 3. So that I have now root of 25 minus 12k, and then I'll close and multiply 2 and 3, giving us a 6. So at this point I can square both sides. So here the square root will disappear. On the other side it will be 36 because 6 squared is 36. So what I've done is I've done this squared. So negative 12k, and then we have 36 minus 25. And then you have negative 12k, 36 minus 25 gives us what? 11. So the value of k is negative 11 over 12. So it is just like the final answer, of course, doesn't matter, but it's like understanding the condition that you're given and trying to see the way you basically get to approach it. So the roots differ by 2. So the easiest way I would go is think of a quadratic formula giving me 2 roots and then put like a difference and then equate to the given value. Okay. Now for the second part, we need to find the roots of this equation where they're equal and opposite. So I'll start with the equal part. Equal. So equal roots, I was explaining this when we were talking about the nature of the roots. So the nature of the roots, we said they are basically equal when under the square root you've got a 0. When the discriminant is equal to a 0, because let's say you add 2 plus or minus 0 over a 2. Here you get 2 same answers. 2 plus 0 over 2 is a 1. 2 minus 0 over 2 is a 1. So these are equal roots. Why? Because under the square root you had the 0. So under the square root there, we call it the discriminant, b squared minus 4ac. So whenever it is equal to 0, the roots are said to be equal. So our b in this case is a coefficient of x, which in itself is k minus 1. So k minus 1 squared minus 4, our a is a 3, our c is a minus 2. So that should be equal to 0. So that is going to be k squared minus 2k plus 1 goes the other side. Negative 4 times 3, that is a minus 12 times 2, that is a positive 24, goes the other side. Of course, we'll maintain it on the same side. So negative 4 times 3 is 12 times 2, positive 24. So I have k squared minus 2k plus 25. So for this one, all you just have to do is, this is a quadratic formula, so solve it using the formula. Quadratic equation, so you use the formula to solve it. Okay, so your a is 1 and all that. So negative of b plus or minus b squared minus 4ac over 2a. So you have 2 plus or minus square root of 4 minus 100 over 2. So I don't know, for me it is diffusing. So the moment you get to a point where you can't like find the values, so since under the square root we've got like a negative thing, so these can only be imaginary roots, they can never exist. So we have no values of k, no real values of k can give us, so satisfy that condition. Okay. Now opposite